Hello everyone, myself Sneha Murthy, studying in Sri Venkateshwara College of Engineering from ISA branch. The subject is optical data structures and the applications, and the topic is optimal binary search. First is introduction to optimal binary search. Optimal binary search are the data structures that allow for the efficient searching and the retrieval of the elements. They are the binary trees that are optimized in terms of the expected search cost. Optimal binary searches are commonly used in the applications where fast search operations are crucial, such as compilers and the database. Here we take an example for a optimal binary search. It is optimal binary tree where the 25, 31, 15, 25, 49, 7 and 12 is there. If we want to search for a 7, the step 1 is first the 7 is smaller than 20, so we have to go to the left side, that is 5. And the step 2 is the 7 is greater than 5, so we have to go to the right. And in the step 3, the 7 is greater than 15, so we have to go to the left side. And the 9 is smaller than 7, so we have to go to the left side. There we can find a 7. So this is a simple example of a binary search tree. And the next is basic concepts of binary search tree. A binary search tree is a binary tree where each node has a key greater than all keys in its left subtree and smaller than all the keys in its right subtree. The key property of a binary search tree enables efficient search operations. In a binary search tree, the left subtree of a node contains the key smaller than the node's keys, and the right subtree contains the keys greater than the node keys. Here we take a same example for searching for a 7. The same example is applicable to those two things. Next is optimal binary search trees overview. Optimal binary search trees are the binary search trees that minimize the weighted average search cost. The weighted average search cost is the sum of the products of the search cost for each key and its probability of being accessed. Construction an optimal search tree involves finding the arrangement of the keys that minimizes the weighted average search cost. And the optimal binary search tree, here is the construction. That is, we have taken an example, and here how we place the 0, 1, 2, 4, 7, 6 and all. Next is dynamic programming approach. What is dynamic programming approach? The dynamic program approach is commonly used to construct the optimal binary search trees efficiently. It involves the breaking down the problem into the smaller subproblems and solving them recursively. The optimal solution is built up from the optimal solutions of the super problem. And this is also a simple example for a dynamic programming approach. And the next is dynamic programming algorithm, that is of step 1. That is, first the step 1 is initialize the cost in the root tables. The cost table stores the expected search cost from subtrees with keys ranging from I to j. The root table stores the root node of the optimal subtree for each range of a case. Here is a C programming example for the dynamic program algorithm. Using namespace int main, int x comma n, count how many numbers will you type in. So this is an C programming example for a dynamic program algorithm. Next is dynamic program algorithm, the step 2. In step 2, what are all the things we have to do? In step 2, we have to calculate the optimal cost and the root values for each subtree, iterate overall possible subtree sizes, and calculate the optimal cost and root values based on the previously calculated values. This is the step 2 we have to do in the dynamic program algorithm. Next, the step 3 is build the optimal binary search tree. Use the root table to construct the optimal binary search tree recursively. Starting from the root node recursively, construct the left and right subtrees until all nodes have been added. So for the step 3, this is an example that how we have to build an optimal binary tree, and we have to use the root table to construct the optimal binary tree starting from the root node recursively from left and right subtrees until the nodes have been added. This is the step 3 of a dynamic programming algorithm. Next is an example calculating optimal cost and the root values. Assume we have the following probabilities for the keys, that is P1 is equals to 0.2, P2 is equals to 0.15, and P3 is equals to 0.1, P4 is equals to 0.1, and P5 equals 0.2, P6 equals 0.25. Calculate the optimal cost in the root values for each subtree using the dynamic program algorithm. So this is an answer for the calculating the optimal cost root values for each subtree. And the next is example, the building the optimal binary search tree. Based on the calculated optimal cost and the root values, construct the optimal binary search tree. Start with the root node and recursively add the left and right subtree based on the root values. Here is a simple example, that is 3, 1, 4 and 2. And the next one is time complexity analysis. The time complexity of the constructing an optimal binary search tree using dynamic programming is O n cap 3, where n is the number of keys. This is because we iterate over all the possible subtree sizes, resulting in the 3 nested loops. However, the dynamic programming approach allows us to solve the problem efficiently compared to the other approaches. Here, the computing complexity of optimal binary tree. Optimal binary search tree. First, to evaluate the optimal binary tree, we need to compute Cij for j minus I equals 1, 2 up to n in that order. When j minus I equals n, there are n minus m plus 1 Cij's to compute. The computation of each Cij's can be computed in time, that is O of m. The total time for all Cij's with j minus I equals m is therefore O nm minus m square. The total time to evaluate all the Cij's and Rij's is sigma of nm minus m square equals O n cube. The computing complexity can be reduced to O n square by limiting the search of the optimal to the range of Rij minus 1 according to the given formula. And the next is space complexity analysis. The space complexity of constructing an optimal binary search tree using dynamic programming is O n cap 2. This is because we need to store the cost and the root tables of the size n into n. The space complexity can be further optimized by using an efficient data structure to store the tables. And the first example only we have taken to the space complexity analysis. And the next is applications of optimal binary search trees. Optimal binary search trees have various applications in computer science and information retrieval. They are used in a computer for efficient table management. Optimal binary search trees are also useful in database systems for inserting and searching. And the next is advantages of optimal binary search trees. Optimal binary search trees provide efficient search operations with minimized search costs. They are suitable for applications where fast retrieval of elements is crucial, such as compilers and the databases. Using optimal binary search trees can lead to the significant performance improvements compared to regular binary search trees. Here, we now want to focus on the construction of a binary search tree for a static set of the identifiers anyone searches are performing. To find an optimal binary search tree for a given static file, a cost measure must be determined for the search trees. It's reasonable to use the level number of a node as a cost. These are the advantages of the optimal binary search trees. Next is limitations and the consideration. The dynamic programming approach for constructing optimal binary search trees may not be feasible for large datasets due to its time and space complexity. Other approaches such as heuristics or randomized algorithms can be used for approximating optimal solutions in such cases. The choice of probabilities for the keys greatly affects the accepted search cost, and the careful considerations should be given to the determination. So these are the limitations and the considerations for the optimal binary search trees. And the next is final part, that is of conclusion. Optimal binary search trees are the data structures that minimizes the expected search cost. They are constructed using the dynamic programming approach, which breaks down the problems into smaller subproblems. Optimal binary search trees provide efficient search operations and are widely used in the various applications. Those applications which we see in before slide itself. And the optimal binary search tree is a key A, B, C, D, and the probability they have given is for A 0.1, for B 0.2, for C 0.4, and for D 0.3. And for this, they have given a cost is 2.9, and for this optimal binary tree, the cost is 3.4. This is all the conclusion about optimal binary search tree. Thank you.